No. Okay. So, what angle relationships are created when parallel lines are intersected by a transversal? So again, parallel lines, transversals, identifying angle pairs. So it says identify the pairs of angles of each type made by the snowmobile tracks. So we've got some snowmobile tracks going across this way. Those are parallel. The snowmobile that's riding away through the middle of them is going across a transversal because it's cutting through the other sets of tracks. And so what it's showing here is that angles 4 and 8, 1 and 5, 2 and 6, and 3 and 7 are called corresponding angles. All right, so 4 and 8, 1 and 5. So I'm going to do a little, I'm going to do some highlighting in blue for these ones. And we're going to do different, I'm going to do different colors when it comes to different letters as well. If you have highlighters, feel free to follow along with this. Colors are always, maybe a nice way to identify some things. So it says 4 and 8. So 4 and 8. Actually, I'm just going to do 1 and 5 as the example here. But keeping in mind that 6 and 2, 3 and 7, 4 and 8, those are also corresponding, but I'm just going to do one example of corresponding here, 1 and 5. How would you describe what's going on here? So 5 and 1 are corresponding, okay? 6 and 2 are corresponding, 8 and 4 are corresponding, and 7 and 3 are corresponding. How would you describe what corresponding angles are based on how they look here? Just in general. What's that? They are the same angle, for sure, which we will learn later on. In terms of how to find them, so if I were to say, how would you describe how 5 and 1 relate to each other in that diagram? Aside from them being the same angle, which they are. Okay, they're on the same side of the transversal, yes. So like 5 and 1 are on the same side of the transversal, yep. 6 and 2 are on the same side of the transversal. 8 and 4 are on the same side of the transversal. 7 and 3, those are on the same side of the transversal. So that is that's one stipulation. They have to be on the same side of the transversal. And what do we think? Yeah, they're each like, at least 5 and 1 are like on the top of the parallel line, whereas 6 and 2 are on the bottom, right? Let me give you some more words to describe real quick. So there are 2 major types of angles when you're talking about transversals with parallel lines or even non-parallel lines in a transversal. There are what we call exterior angles and what we call interior angles. So which ones do you think would be exterior here? 5 is, 1 is not an exterior angle though. 2 is, 5 is, 8 is, and 3, yeah. So exterior angles just mean the angles that are not in between the 2 parallel lines. So up here, so if I just point to, I'll do this, point to 5 and point to 8, those are exterior. And then 2 and 3 are also exterior. Because if you look at where those parallel lines are, if you look outside of them, not in between them, on the outside would be exterior. In between would be interior. So which ones are interior? Which angles are in between the 2 parallel lines? 4. Yeah, what else? 1, what else? 6 and 7, yeah. So there are 4 angles that are interior. There are 4 angles that are exterior. The interior. These are also interior. So half of them are interior, half of them are exterior. So corresponding angles, there we go, corresponding angles. They are on the same side of the transversal, and one of them is interior, one of them is exterior, right? So if you look at the same side of the transversal, one is exterior, one is interior, and 5 and 6 are not exterior, interior, they're non-adjacent. They cannot be next to each other. So basically, it's like every other angle on the same side of the transversal. 5, skip 6, go to 1. 5 and 1. 6, skip 1, go to 2. 6 and 2. On the opposite side. 8, skip 7, go to 4. 8 and 4. 7, skip 4, go to 3. 7 and 3. So those would be corresponding angles. So every other angle on the same side of the transversal is corresponding. Other types, we have 2 and 8, 5 and 3 are alternate exterior angles. What do you think it means by alternate exterior angles? They're both exterior, okay. And what do you think it means by alternate? It says 2 and 8 and 5 and 3. So I'm going to highlight 2 and 8. Yeah, 5 and 3, and it looks like 2 and 8 are equal to each other. It looks like 5 and 3 are equal to each other, which is true. What do you think it means by, so exterior means it's on the outside, they're both outside. What do you think alternate means here? What's that? Well, they have the same angle measurement. What do you mean by not the same? Right, but that's a good point. You're correct about that. However, we're only matching up the 2 at a time. So like 2 and 8 are alternate exterior to each other. They're not alternate exterior to 5 and 3. They're only alternate exterior to one another. So 2 and 8 are alternate exterior angles with each other. 3 and 5 are alternate exterior angles with each other. So Zach, what do you think alternate means? Closer. They are on alternate sides of the transversal. Yeah. This one's on the left, that one's on the right, and they're both exterior. So, opposite sides of the transversal on the exterior. Opposite sides of the transversal, both on the exterior. Now, with corresponding, there were 4 pairs of corresponding angles. With alternate exterior, there's only 2 pairs of alternate exterior angles because there are only 4 total exterior angles, which means there can only be 2 pairs. We can't mix and match it. How about these ones here? Alternate interior angles. It says 7 and 1 and 6 and 4 are alternate interior angles. Thoughts about that? Yeah.
Opposite sides on the.
Yeah. Alternate, we've established, means on the opposite side of the transversal, but this time we're talking about interior angles as opposed to exterior. So there's 2 pairs of those. What does it look like angle-wise? Same, yeah. So corresponding angles, I should have highlighted that in blue as well. Corresponding angles, alternate exterior angles, and alternate interior angles, all of those pairs of angles appear to be equal to each other, which is true. If the lines are parallel, I need to make that really clear. The only time they're actually going to be equal to each other is if you have parallel lines. Because if these lines are not parallel, the transversal cutting through them, you would still have corresponding alternate exterior and alternate interior. You just wouldn't have that relationship of congruence. So you'd still call them that. You just wouldn't be able to say they're equal. Now there's another type that we're going to be talking about as we go a little bit further, but this is kind of where we're starting. And so it says transversals can intersect either parallel or non-parallel lines. So they could be parallel, they might not be. If they're parallel, then you have those mathematical relationships. If they are not parallel, then you don't have those mathematical relationships of the angles being equal. So let's identify some stuff here. So for part A, which angle pairs include angle 4? So of these 3 up here, of these 3 types of angles, which is angle 4 a part of? Yeah.
Corresponding and alternate.
So angle 4 corresponds to angle what? Eight. Yes. Does everybody see that? Angle 4 corresponds to angle 8. And I always abbreviate corresponding as CORR. So we're saying angle 4 corresponds to angle 8 because they are on the same side of the transversal. 8 and 4 are on the same side of transversal, and it's every other. 4, skip 6, go to 8. 4 and 8 are corresponding. What is the other angle relationship that angle 4 has? Is angle 4 an exterior or an interior angle? Interior. So what angle relationship do we have that uses the word interior? Alternate interior angle. Okay. So angle 4, alternate interior with angle 5. Good. Are there any questions about that before I have you do B on your own? And I would say with B, write that down here because I don't know why they put something right so close to the diagram. Write your answer for B down below here. But angle 4 corresponds to angle 8, and angle 4 is alternate interior with angle 5. Everybody see that? Are there any questions about the visual aspect of that? We're just identifying the names of them right now. So we're building some vocab before we start doing math with it. All right, try B on your own. See how that goes. Angle 7. By the way, you'll usually have, in terms of what we're looking at so far, there will be 2 different relationships that the given angle has with other angles. So we are going to add one more relationship when we get to the thing at the bottom of this page. But for now, just say what 2 relationships angle 7 has and with what angles. When you do that, I'll take attendance because I haven't done that yet. Gabe's here, Diego's here. Andres, Jovi, no. I think there's a lot of people gone. Yes, here, no Syra. Dolphin, Venus here. Yes, here. Caitlin, no. Notice here, no money. Exact Meyer, Shelter. Kristen, yes. Brian, no. Levo. Usually with you, no question. Okay. 1, Okay. All right, so angle 7. What is one relationship that angle 7 has with another angle? Gabe, go. Yes, excellent. Angle 7 corresponds to angle 3. Nice. This is for part B. Angle 7, somebody else. Another relationship that angle 7 has to another angle. Not named Gabe or Zach right now. Someone who maybe hasn't given a lot today. What's that? Alternate exterior, good, with angle 1. Excellent. There we go. It corresponds to angle 3. It's alternate exterior with angle 1. How are we feeling about that? Okay. Visually, we doing okay? We're just pointing things out at this point. If you're having a hard time seeing it, please let me know so I can kind of try to explain it in another way if I can. Otherwise, we'll move on because we have one more angle relationship that we need to discuss. So we've got corresponding, alternate exterior, alternate interior. Don't forget about linear pairs. Don't forget about vertical angles. Those are going to come into play today as well, the ones that we learned before that we talked about on the warm-up. The one more that we need to talk about is right here. Same side interior angles, which to me seems a bit self-explanatory. They're interior angles and they're on the same side of the transversal, right? So if we look at this original diagram, which ones would be same side interior angles? Yes, what else? 6 and 1, yeah. So those would be same side interior angles, good. Now, there is a mathematical relationship if the lines are parallel, but it is not that they are congruent. If the lines are parallel, corresponding alternate exterior, alternate interior, those are all congruent. if you have parallel lines, the same side interior angles are, what does it say? What does this say that the same side interior angles are if you have parallel lines? They equal 180. They are supplementary. So that is the other relationship that I mentioned on the first page. So you can either use same side interior angles to say that angles are supplementary, or you can use linear pair to say they're supplementary. Or you could use corresponding, alternate exterior, alternate interior, or vertical angles to say that they're congruent. So that's what we got going on today. Same side interior angles are congruent as long as the two lines that the transversal cuts through are parallel. That's what we got. So let's keep going. What's up, Noah? Oh, it's real. All right. Dang. All right. Let's see. Where am I going here? Right here?
No.
What's
up, Noe?
What
What's the paper for? Just something. You something like that. I got you.
Okay.
Say hi.
Let's see. Good.
Nah, you couldn't. I can't do it. I couldn't move it tonight. Then I keep doing the same. I looked up there. Me too, bro. Me.
All right, here we go. Let's keep going. So example 2. How can you express each of the numbered angles in terms of x? So this is an interesting question, but let's just go ahead and talk about what we got so far. Which of the other angles in this diagram, or which of the angles in this diagram are equal to x? Somebody tell me, which of these angles in this diagram are equal to x? 1, 3, and 7. Good. Angles 1, 3, 7, and x are all congruent. Okay, so 1, x, 3, 7. All 4 of those are congruent to each other. Because, well, there's a lot of different reasons, right? This is where you get options. You ready? X and 7 are congruent because they're vertical angles. X and 3 are congruent because they're alternate interior angles. X and 1 are congruent because they're corresponding angles. 1 and 7 are congruent because they're alternate exterior angles. 7 and 3 are congruent because they're corresponding angles. Like there's a lot of different ways. 1 and 3 are congruent because they're vertical angles. All those different relationships are happening all at the same time. So it says the angle with measure x and angle 7 are vertical angles. Both 6 and 8 form a linear pair with the angle with measure x. We'll talk about that in a second. But those 4 are all congruent. So we can just say that the measure of angle x is equal to the measure of angle 1. And we're just going to keep this equation going. Is equal to the measure of angle 3 is equal to the measure of angle 7. So we're just basically saying all 4 of those things are equal to each other. That's all we're saying. Now we also know that 2, 4, 6, and 8 are also all equal to each other. So I'm just going to go ahead and highlight those. And then we're going to write this. You ready? We're going to say measure of angle 2 equals the measure of angle 4 equals the measure of angle 6 equals the measure of angle 8. Write those 4. Okay. So we got pink for those ones, green for these ones. Question for you. If x, was it up? If x equals 80,
Yes.
what do all those equal? Eddie, was it up? Eddie. If x equals 80, all of these equal 80, which means all of these equal what? 100. Why do you know that? Because the line equals 180. So real quick, what could we say about the measurement of these angles if we don't know what x is? What did you do to get 100 for these ones?
I don't know.
Well, if these are all 80, so Gabe, if these are all 80 degrees, all of these have to be 100 degrees. Because the two pairs of angles will always be supplementary. They will always add up to 180. So 4 of them will be 1 degree. 4 of them will be whatever's supplementary to that degree, no matter what. So what do you do to get 100 if you know that this one's 80? Subtract. Yeah. So that means that these angles, if we don't know what x is, would be 180 minus x. Because if x is 80, 180 minus 80 would be 100. So whatever x is, these are all x, but 180 minus x. Because they're all supplementary to it. Supplementary means if you have one angle, you take away that angle from 180 to get the other one, right? Some subtraction. So in terms of x, these are all x, these are all 180 minus x. Questions about that?
Huh?
So let's say the measure of angle x is 60. How about that? That one's 60, that one's 60, 60, and 60. Okay. How many degrees would these be? If these are all 60, those are all what? These 4 angles have to be supplementary to those 4 angles. So if these are all 60, these all equal 120, because that's what you add with 60 to get to 180, right? But if you take 180 and you subtract 60, you get 120. So whatever x is, these are 180 minus that. If this is 45, these are 135 because 180 minus 45 is 135. If these are all 90, those are all 90 because 180 minus 90 is 90. If these are all 10, these are all 170 because 180 minus 10 is 170. So if these are all x, these are all 180 minus x. So let's keep going. Let's use some more numbers here. Here we go. For parts A and B, use this figure to the right. If the measure of angle 4 equals 118, what is the measure of each of the other angles? So, measure of angle 4 equals 118. And by the way, if there's a diagram and it gives you a number, go ahead and put that number on the diagram. So this is 118 right here. 3 of the other angles will be equal to that. What 3 angles will be equal to 118 aside from the one we already know? 2, good, 2, 6, and 8. Yeah. So 2, 4, 6, and 8 are all 118. Okay. So what is the measure of each of the other angles? Well, let's see. Measure of angle 2 equals the measure of angle 6 equals the measure of angle 8 equals 118 degrees. This is just a way of writing multiple angles that are the same all at the same time. That way we don't have to say measure of angle 2 equals 118, measure of angle 6 equals 118, measure of angle 8 equals 118. We're just saying they're all the same, they're all 118. Just write them all at once. Now, the other ones, let's write this down. Measure of angle 1 equals the measure of angle 3 equals the measure of angle 5, which equals the measure of angle 7. How many degrees are each of those? 180 minus 118, because the 2 angles in this diagram have to add up to 180. So how many degrees is that? 62. Good. 118 plus 62 equals 180. 4 of the angles equal 118. The other 4 equals 62. So in any diagram like this, there will ever only be 2 different angle measurements. It will get more complex as we go on, but we're just kind of building some stuff right now. Any questions about that? How are we feeling so far? Decent? Does this feel more like a regular lesson? I know the last 2 units have been a little bit weird. We did proofs, then we did a bunch of stuff on grids and did rules for rotations and stuff. But now we're getting back to like normal, quote unquote, normal geometry. All right, here we go. If the measure of angle 2 equals 9x minus 12, and the measure of angle 4 equals 6x plus 30, what's the measure of angle 5? Ooh. What do you think we have to do first on this one? There's a variable. What do you think we should do with that variable? Figure out what it is. Okay. So what is the relationship between angle 2 and angle 4? But what's the relationship on the diagram between angle 2 and angle 4? They're across from each other, meaning they are vertical, meaning they are congruent. They're equal to each other. Yeah. So 2 and 4 are congruent. So what's the equation we're going to write in order to solve for x? First thing I'm going to do is I'm just going to say measure of angle 2 equals the measure of angle 4. Because they're equal. They're congruent. They have the same angle measurement. So what we can do is we can take what they're each equal to and plug them in here. So we're just going to set these two things equal to each other. It's going to be like a normal algebra equation. So we're going to say 9x minus 12 equals 6x plus 30. Because the measure of angle 2 is 9x minus 12, and the measure of angle 4 is 6x plus 30. So those have to be equal to each other. Let's solve for x. What do we do next? How do we solve for x here? Straight up algebra, what are we doing? Okay, minus 6x from both sides. So that's going to be 3x minus 12 equals 30. Then what? Add 12, good. 3x equals 42. Then what? Divide by 3. Okay, what's 42 divided by 3? 14, okay. Is that the answer to this problem? No. That's what x equals, but that's not the answer to the problem. The answer to the problem is the measure of angle 5. Neither of these things is angle 5, but it's going to help us to figure out angle 5. So for this particular problem, 118 probably not going to be the measure of angle 2 or 4. So we don't need that 118 right now. We can ignore that. How do we figure out the measure of either angle 2 or 4 right now? Yeah, measure of angle 2 equals 9 times 14 minus 12. How many degrees is angle 2? Feel free to use a calculator. $114, good. 9 times 14 is 126. 126 minus 12 is 114. Good. So 114 degrees for that one. Now, just to double check, here's a great way to make sure you solve for x correctly. Plug x back into the other angle and see if you get the same measure. It should be the same. So I'm going to do the same thing here. Measure of angle 4 equals 6 times 14 plus 30. Let's see. 6 times 14 is going to be 60 and 24, so that's 84. 84 plus 30 is 114. So they're both 114, which is good. That means they're equal. That means we solve for x correctly. So if angles 2 and 4 are both 114 degrees, how many degrees is angle 5? That's the question here. We want to know how many degrees angle 5 is. 66 degrees. Why? Equals 66 degrees. Nice. There it is. Question for you. What is the relationship called between angles 2 and 5 in that diagram? 2 and 5? 2 and 4, yeah. 2 and 5 is one that we just learned on the last page. Bottom of the last page. There it is. Same side interior angles. Nice. And they are supplementary. They have to add up to 180. 66 plus 114 equals 180. All right. How are we doing? Lots of 180s in this. Lots of 180s, lots of congruence going on. All right. The next thing is something that we've already learned that we kind of figured out on our own. Alternate interior angles theorem. Alternate interior angles are congruent. So on the diagram, just go ahead and put the congruent markings on there. If the lines are parallel. If the lines are not parallel, this does not work. But if the lines are parallel, this does work. Cool. All right. We already talked about that. Flip the page. We've already talked about these ones as well. Corresponding angles. If the lines are parallel, corresponding angles are congruent. So go ahead and put the markings on that one. These are just some theorems that we're introducing. These are things that are true about these types of diagrams. The next one, alternate exterior angles. We've already talked about this one. If the lines are parallel, alternate exterior angles are also congruent. So we got 4 things today. Same side interior angles are supplementary. Corresponding, alternate interior, alternate exterior angles, those are all congruent. So long as what?
They're
Parallel lines. Yeah, the lines aren't parallel, that doesn't work. All right. Here's a question. Suppose a transversal intersects a pair of parallel lines and one of the interior angles created measures x. What must be true of the other interior angles created? Well, let's draw it. There's some parallel lines. Here's a transversal. Interior angles. Oh, wait, we need to make sure that these are parallel. Hang on. So there's a parallel arrow there. There's another one. Okay, parallel lines, transversal. The interior angles are going to be the ones that are in between. So like one of them has a measure of x. So let's just say that one's x degrees right there. If this one is x, is there another one in there that is also x?
well,
What's that? Yeah, which one? Let me number these. 1, 2, 3. Which one is equal to x? 3, because they are what? What do we call those? Yeah, alternate interior angles. So measure of angle 3 equals x. Okay. Now the measure of angle 1 is equal to the measure of angle 2 because those 1 and 2 are also alternate interior angles, so they have to be equal. This is going to go back to example 2 at the top of the previous page. Example 2 at the top of the previous page. We've already done this problem. What are those going to equal? It's either x or what? 180 minus x, yeah. There you go. No matter what, one of the angles is something and the other is 180 minus that something. So if it's x for one of the angles, the other one's going to be 180 minus x. All right, let's keep going. Now we get to talk about barns, which I know you are all looking forward to. So, example 5, finding angle measures. There's a lot more going on in this diagram, so we're going to go ahead and ratchet up the complexity a bit, huh? All right, the white trim shown for the wall of a barn should be constructed so that segment AC, by the way, those double lines right there, that means parallel. So this is probably something we should put in here. This symbol right here, that means parallel. Make sure I move that so you can actually see it. If you see double lines in between sets of letters, it's just saying that 2 segments or 2 lines are parallel to each other. That just means parallel. So the white trim shown on the wall of a barn should be constructed so that segment AC is parallel to segment EG, segment JA is parallel to segment HB, and segment JC is parallel to segment KG. What should the measure of angle 1 and the measure of angle 3 be? So let's investigate. Now the diagram's already been drawn for us, which is nice. It says you can create a simple drawing of the wall of the barn so that the angles are easier to visualize. Look for relationships among the angles. Relationships being old ones, vertical, linear pair, new ones, corresponding, alternate exterior, alternate interior, same side interior. Like 6 different things that we have possibilities of here. All right. So Down on the diagram, let's go ahead and mark the things that need to be parallel, because we were told a few things about segments that need to be parallel to each other. AC, the distance between A and C needs to be parallel to the distance between E and G. So I'm just going to go ahead and do that and that. AC and EG are parallel. It tells us that. It also says that JA needs to be parallel to HB. Now, when we have more than one set of parallel lines, we have to add some arrows. So single arrows on AC and EG, double arrows on JA and HB, which means we need triple arrows on JC and KJ. Sorry, KG. Did I say KJ? KG. JC and KG. All right. 1, 2, 3, and 1, 2, 3. So 3 different sets of parallel lines happening here with multiple transversals cutting through, doing all their things. We need to figure out the measure of angle 1 and the measure of angle 3. So just to keep that in mind, I'm going to go ahead and highlight angle 1 and angle 3, just so I know. I don't want to lose track of what I'm actually trying to figure out, because there's a lot happening. So we are starting off with the same side interior angles postulate. It gives us a little bit of a head start by saying, hey, let's use that first. So my question for you is, would you agree that angle A at 68 degrees here and angle 1 are same side interior angles? Yeah, because A to E and B to F are parallel, right? And then here's a line here, AB, or segment anyway, that comes into contact with both of those, which means that AB is a transversal of AE and BF. Good with that? 2 parallel lines, transversal. Those would be in between the parallel lines, and they're both on the same side of the transversal, which means they're same side interior angles. So we are going to say that 68 plus the measure of angle 1 equals what? Same side interior angles have what mathematical relationship? There's that postulate 2-1 right at the beginning of our notes. It said something about if you have parallel lines and you have same side interior angles, the same side interior angles are, yeah, they're supplementary. They add up to 180. So get angle 1 by itself. What do? Yeah, subtract 68 from both sides. So measure of angle 1 equals what? What is it? 112 degrees? All right. So that's one of the 2 angles we need right there. What's the other one we need? Which one? 3. Yeah, we need the measure of angle 3. So, well, let's see. We've got some other things happening here. There is another numbered angle on there. That might be useful. What's the other numbered angle other than 1 and 3? 2. Right here. The fact that there's an angle 2 on there, maybe there's a suggestion that we could potentially use that for something. What's that? You think 3 is 68? Mm-hmm. Mm-hmm. Okay. Okay. I hear what you're saying. So you're saying that because EG is parallel to AC, that means that this is a transversal of these 2, which means that angle 1 and this angle right here where F is have to be same side interior as well, right? Yeah, I would agree with that. So we don't actually need to use angle 2. It's there. We could have used it, but we don't need to. I like what we're doing here. So let's try to figure out the angle at point F right here. Because, so parallel lines, transversal, same side interior. If that one's 68, this one is supplementary to that. No, sorry, if this one is what was it, 112? If this one is 112, this one is supplementary to that, which we already know is 68 because we already did that math. So, everybody, does that make sense how we kind of figured that out? So we're going from one to the other, which means that this angle right here, let's see, I'm just going to draw an arrow right there. We'll call that 68 degrees. We cannot call that angle F, just so we're clear. That is point F. There are 1, 2, 3, 4, 5, 6 angles at point F, so we cannot call that angle F because there are 6 possibilities for what angle F could mean. So we're just going to draw an arrow and call that 68 degrees. Now, Zach, you said that angle 3 was 68. Why? Yeah. This 68-degree angle right here and angle 3 are vertical because they're right across from each other where these two lines intersect. So this angle is congruent to that one because they're vertical. That means that the measure of angle 3 equals 68 degrees. There we go. That's our answer. How's everybody doing? Doing okay about this today so far? Hopefully it's feeling maybe not as challenging as the last couple of units we just got through with proofs and with transformations and stuff. More like normal math. All right. Anybody need more time before we continue? I think we only have one more to go, right? Yeah, one more quick. What's that?
He said, let's go.
Let's go. One more quick example. Same original diagram. I want you to try to work through the rest of this on your own. The angles, by the way, are the same as what they were on the last page. You're just figuring out a different angle measurement. You're trying to figure out the measure of angle FHK, given that the measure of angle EJF is 56 degrees. So first of all, angle 3 is still 68. Angle 1 is still 112. The top angle here at point F is still 68 degrees. All those things are the same. So EJF, let's go. I'm just going to go and show you where that is. So if you go from E to J to F, so here's E, here's J, here's F. EJF, that's this one right here. That's EJF. That's 56 degrees. You need to find the measure of angle FHK, which is right there. So mark up the diagram with whatever parallel markings you want. It's the same parallel markings that we had on the previous diagram because it's the same diagram. We're just finding some different angles in here. Let's go with 3 minutes. So right around 11:39, 11:40, we'll check back in and then we'll be done. Because everything down here, this is just a recap of all the stuff that we learned. So this is not new information. This is just taking all those different things and putting them in the same place at the end of the notes. So try to answer this up. Work together on this if you want to. Feel free to pair up, group up, figure out the measure of angle FHK. 3 minutes. At this point, are you just wishing I wouldn't have shown you the stuff from the algebra two? Give it a try, see what you can get. Work through some things that you know about. Also, it might be important to remember that triangles add up to 180 degrees. That might be useful in it. I'm not saying it is or isn't, it could be. Triangles add up to 180 degrees. Maybe that's useful in some way. Angles. Each angle in a triangle adds up to 180. Not each angle. The three angles of a triangle add up to 180 degrees. Yeah. The sum of the three angles in a triangle always adds up to 180. So that might be helpful as well. By the way, you're going to have to figure out some other angle measurements before you can just go straight to the answer. So you're going to have to fill in a little bit more of the diagram in terms of angle measurements before you can actually tell what the angle is. And there are multiple paths you can take to get to the answer. You want another hint? As far as I can tell, the last step in this problem will be using the fact that you have a linear pair. By show of hands, who could use some help on this one? Anybody? Anybody want some help? Or do you want to keep working on it? All right, keep working on it. I don't see any hands. All right. Keep at it. See what you can come up with. Let's. How many degrees is angle two? Yeah. Angle two is 68 degrees. The reason for that is it corresponds to this one up here. This angle up here at A and angle two are corresponding angles. Because we've got a parallel line here and here with a transversal here. So 68 and this are on the same side of the transversal, but they are skipping an angle. So we got here, skip this one here, go to 2. So 2 is 68 degrees. I'm just going to draw an arrow to 2, call that 68. If the three angles of a triangle add up to 180, that means that 68 plus 56 plus this one here add up to 180. So 68 plus 56, take that away from 180. This angle here is also 56. So that one's 56. A little closer. Something I want to show you off to the side here. You ready? If I were to draw from J to C, right here, here's J, here's C. And if I was to draw from K to D, right there, K and D, I'm just kind of taking those and drawing those like that. And then if I were to draw from B down to H, like that. So here's H, here's B. Basically what I'm doing is I'm decluttering the diagram so we can focus on just a little part of it. Would you agree that this angle here and that angle there are congruent because of what? What are those called in relation to each other? The name for that. Are they in between the parallel lines? Okay, so are those exterior or interior? Interior. Are they on the same side of the transversal or are they on opposite sides? So what are they called? Alternate interior angles. Good. So they're congruent. So if we can figure out this angle here, which is that one right there, that means that this one would equal to that one, which means the angle that we want, this one right here, has to be supplementary to this one. There's a couple more steps to go through. Like there's a lot of little things that we need to fill in here. This is the angle we're trying to get. If we can figure out this one, it's got to be supplementary to that because those two would make a linear pair. So what do you think, Zach? How many degrees is this angle right here?
Oh,
Yeah. This one is 56. Good. Take a look. This angle here is the same as this one right here on the diagram. 68, 56, and that angle there make a straight line. Those three angles have to add up to 180. And we've already seen here that 68 and 56 and 56 add up to 180, which makes this one 56 degrees as well. Okay, if this one is 56 right there, this one down here also has to be 56. Okay, take a look. Those two are 56. These two are a linear pair, which means they add up to 180. So the last step, take away 56 from 180. 124. 124. 124. So the measure of angle FHK equals 124 degrees. There were a few things there that had to happen. That's not the only way to get that answer, by the way. There are other ways to work your way through that diagram to figure it out. If you used another method to get there, great. My advice for you is, if you don't know what the answer is, start filling in as many angles as you can figure out. Because eventually, the more you fill in, the fewer there are left, which is going to make things a little bit easier that way. So if you don't know what path to take, just start filling in angles that you can figure out. And eventually you'll get to where you need to go. All right, go and get your stuff packed up. I will get the assignment handed out.